This is the second lesson for Chapter 9 on sequence series. I got a nice little start-off sequence for you, JPG. Give you a hint, music for that one. DDPV, I can't remember that one. 3 you should be able to get pretty easily. And then 4, think year for number 4. All right. Important formulas we have so far. Well, let's do the arithmetic ones. Arithmetic will be common difference is a of n plus 1 minus a of n. And then for geometric, the common ratio is a of n plus 1 over a of n. Then for the nth term, we start with a, and then we add, for arithmetic, something. For geometric, we start with a, and then we multiply by something. So for the arithmetic, we're going to take the number of terms minus 1 times the difference. And for geometric, we're going to take the ratio to the n minus 1. Because for arithmetic, we started with a and we added differences minus 1 because we didn't add to the first one. For geometric, we took the first term and we multiplied by the ratio every number term we have minus 1 because we didn't do the first one. So those are the 4 that we have so far. These green ones are arithmetic, and the purple ones are geometric. Hopefully those are starting to sink in. Well, today what we're going to look at is not only are we going to look at the formulas for adding them up, we're going to look at a brand new symbol that we use in calculus called sigma notation. And sigma notation means 2 things. You add the terms and you increment the n, or in this case I, by 1. So you increment I by 1 and you add those terms up. So for example, if you had an equation 3 plus 2i, well, it says that I starts at 1. So 3 plus 2 times 1, 3 plus 2 is 5. Okay, that's the first one. Now we're not going to put a comma because we're going to, sigma means to add the next term. So then we're going to crank I up by 1. It doesn't go by half, it goes by a whole integer. So now it's going to be 3 plus 2 times 2. And then we're going to crank it up again by 1, 3 plus 2 times 3. Well, we're going to keep doing that until we get to the last of these, which is n equals 6. 3 plus 2 times 6. So if you look at these that I've already written here, 3 plus 2 is 5. 3 plus 4 is 7. 3 plus 6 is 9. And then our last one will be 3 plus 12, which is 15. What's neat about this is that look how tidy this is in figuring out each of those terms. And then when you add them up, you'll get an actual answer. And by the way, for arithmetic, there's a quick little trick here. We could add these 2 and get 20, these 2 and get 20, these 2 and get 20. That's a real simple sum of 60. You like that? That's pretty cool. So there you have it, summation notation. You start with an I or an K, whatever you want to use for this variable, and then your formula for finding each term is here. So this is my formula for each term, and then you go from 1 to last value 6, and then you add them up. And so this is equivalent to this. Okay, well, let's try a couple here. Well, these are some properties. Let's do this one, 1 to 3 of 2i. So it's 2 times 1 plus 2 times 2 plus 2 times 3. So you notice you could factor out a 2 and get 1 plus 2 plus 3, which is the same here as saying 2 times the sum of I, which is 1 plus 2 plus 3. Okay. You can break these up into 2 parts. I'm not going to do that, but you could. You could do this 2 times the sum as I goes from 1 to 3 of I, plus 3 times the sum as I goes from 1 to 3 of I. And of course, these are the same quantities, which is 6. So you could go 2 plus 3 is 5 times the 6, which will be 30. But you can break these up. So this one, I didn't finish this. So this is k times the sum as I goes from 1 to n of your formula. This could be the sum as I goes from 1 to n of u plus I goes from 1 to n of v of I. You can break that up. Now this is the one that's really interesting. Let's say the sum as I goes from 1 to n of k. Now this seems kind of boring, but it's actually tricky for some people. What we're saying is we're putting a 1. Think of this as, let's rewrite this as the sum as I goes from 1 to 3 of 22 plus 0 times I. That might help a little bit. So put a 1 in, you get 0 plus 22. Then put a 2 in, you get 2 times 0 is 0 plus 22. And then put a 3 in, you get 3 times 0 plus 22. Isn't that just the same as 3 times 22? Or in this case, n times k. Now when you see this formula, it looks kind of cryptic, n times k. But when you see it in the context of a real problem, it totally makes sense. So there are your 3 properties, plus 1. Okay, and you can use those to figure these out, or you can just figure them out. Now, if I were to give one piece of advice, my advice is for sigma notation, list the terms out so you make an arithmetic or geometric, and you can see them pretty well. So, for example, this one is going to be 3 halves to the 1. Then it'll be 3 halves to the 2. Then it'll be 3 halves to the 3, all the way to the 5th. Okay, and then you'd add them up. Well, this is obviously going to be geometric, right? So you're going to use a geometric sum formula, which we don't have yet. We're going to get shortly. This one, 5n minus 2, well, when we put a 1, 5 minus 2 is 3. Then when we put in a 2, 10 minus 2 is 8. Well, notice these are going up by 5, so it'll be 13, and then it'll be 18, and then last one, 25 minus 2 is 23. That one, we are adding the same amount. Okay, so you can see that that's an arithmetic form of the formula to figure that one out, or you can just add them up. So that goes great, but what if you had the series like we have here and you have to generate a formula? Well, what we notice is that for geometric, you're going to have the ratio to the n, okay? And then for the arithmetic, it's the difference okay, for arithmetic, it's going to be the difference times n. So ratio to the n, difference times n. So all you need to do for like 23 is start by saying, okay, what do we have going on in each consecutive terms? Well, it looks like I'm adding 3. So you know your sigma is going to start out at 1, go to n, and we're going to start with 3 times n, or 3 times I. Because I is the formula variable that 3 is the common difference. So 3 times I. Then what I do is I put in a 1. 3 times 1 is 3. What do I do to get 1? 3 minus 2 will give me 1. And then when I put in a 2, I'll get 6 minus 2 is 4. Put in a 3. 3. 9 minus 2 is 7. We're good to go. Now, we got a little challenge here, is that we don't know what n is, so you're going to have to find n, and I'll leave that up to you. How are you going to find that? Do you have a formula that you could do that with? Okay, let's try the next one here. These are all multiplying by 1/4. So that's your common ratio. So you start with I goes from 1 to n, and our common ratio is 1/4 to the n. So when we put a 1, 1/4 times what gives me 8? Well, we're going to have to multiply by 32 for this to work, because 1/4 to the 1 is 1/4 times 32 is 8. Let's see if it works. 1/4 squared is 1/16. 32 times 1/16, perfect. Now this one's nicer because you start with 1, 2, 3, 4, 5. It looks like we're going to go to 6. So there's your sigma notation. So one more time, arithmetic, look for that common difference times n. For geometric, look for that common ratio to the n. And then put a 1 in, and then add or multiply whatever it takes to get that first term that was given. And just remember that sometimes these won't be either. Like this one, I'm adding 2, then I'm adding 6. That doesn't work. Here I'm multiplying by 3. Oh, multiplying by 3. So this is actually going to be a geometric. So we would go I equal 1, and we're going to go, we're multiplying by 3, so it's 3 to the n, and you can go 3 to the n is 1. If we multiply by 1/3, you'll get 1. 3 squared divided by 3 is 3. 3 cubed divided by 3 is 9. So that looks good, and then you'll have to find out what term this is. Use your nth term generator function and figure out what that is. But there you have it. Now some people will write this a number of ways. They might go I equal to 1 to whatever, and they'll go 3 to the n minus 1, because that's 3 to the n times 3 to the negative 1. That's great. Some people will go I equal 0 to something of 3 to the n, because 3 to the 0 is 1. Then 3 to the 3 to the 1 is 3. You can do any of those. But you just need to figure out what that top one is. All right, so with those sums, what we want to do next is figure out a formula for generating the sum of an arithmetic and sum of a geometric. So sum of an arithmetic we're going to do first. Sum of n, what you do is you go sum of n is equal to a plus d, a plus 2d, a plus 3d, all the way to a plus n minus 1 times d. And this is, I'll just take that out. Now, what I'm going to do next is I'm going to write the same thing below it, but I'm going to reverse the order. So this is going to be a plus n minus 1 times d. And then this a plus d is going to be added to a plus n minus 2 times d. And then this next one is going to be a plus n minus 3 times d. And then that next one will be a plus n minus 4 times d. And then when you go to the end here, at the end, you're going to have a, you're going to be a plus d, you're going to have a plus 2d. And so when I add these up, you're going to get s of n plus s of n is 2s of n, two sums, and then you're going to have a plus n minus 1, or you're going to get 2a plus n minus 1 times d. And then you're going to have another one, and notice one of the d's will cancel, so it'll be this again, 2a plus n minus 1 times d. And then you're going to get it again, and you're going to get it again, and you're going to get it again, n times. So this is going to be, I'm going to write this in blue, 2s of n will be n of the 2a plus n minus 1 times d. If you divide by 2, you're going to get n over 2, 2a plus n minus 1 times d. Not a super friendly formula, but it's correct. Going back here, I'm going to show you a quick little deal. If I were to add 1 to 10, notice that I have 11, 9, 12, right, excuse me, 1 and 10 is 11, 2 and 9 is 11, 3 and 8 is 11. All of these are going to be 11. It looks like we have 5 11s. Works the same thing with 51s. You're going to have 25 51s. You're going to have 50 101s. So essentially what you're doing is you're taking the number of terms and divided by 2, n over 2, and you're taking the first term plus the last term. You're taking 1 and 10, 1 and 50, 1 and 100, and you're multiplying by n over 2. Well, look at this. If you're looking for the sum formula, you got it here. You have a plus before a plus n minus 1 times d. Well, how many of those a's do you have? Well, I have 2 a's and n minus 1 times d. And so we derived it a different way. I love this formula because sometimes in problems, this will be much more useful than this one. But they're both good. This is for arithmetic, and so you can find the sum with that. And you can practice those, no problem. Okay, let's do geometric quick. We're going to add those. You can't use that sum formula for arithmetic. You're going to have to use something different. So what we're going to do here is we're going to take the sum formula for geometric, a times r squared, and so on, all the way to the last term, ar to the n minus 1. And this time I'm going to duplicate sum formula, but I'm going to multiply it by r. So sum formula, a plus ar squared, and so on, we're going to multiply everything by r. So a times r is a times r squared, or a times r is ar squared, and so on. Notice that essentially these get shifted over. Now what I'm going to do that you can probably see is I'm going to subtract this in a column and get s sub n minus r s sub n. And then on this side, all of these are going to cancel, except for 2. You're not going to take this one, and you're not going to take this one. So that's going to be a, this should be minus a r to the n. So this isn't very nice looking, but you get s sub n times 1 minus r. I'm going to pull a s sub n out, leaving 1 minus r. I'm going to take an a out, get 1 minus r to the n. Then if I divide by 1 minus r, I'm going to get 1 minus r to the n over 1 minus r. And that's your formula for geometric. The ratio can't be 1 because if the ratio is 1, you can't tell it from a geometric. So let's say you had 3. You can't tell an arithmetic from a geometric. 3 plus 3 plus 3 plus 3. Is that arithmetic or geometric? Well, I'm adding 0 or I'm multiplying by 1. So this formula doesn't recognize that, even though you could just say this is the term a times n. You could figure that out, but we can't use this formula, so to speak, when r is equal to 1. So we exclude that. So those are all those. Here's some information about calculator usage. I'm not going to go over this at this time, but you can look this over and add things up, be in sequence mode. Let's just do a quick little example. Logs of wood are stacked in a pile, so there are 15 logs on the top row, 16 on the next, 17. There's a sum of 246. So the sum is 246. The first is 15, and it looks like a common difference is 1. So how many rows are there? Well, let's see here. You could figure out what n is with the two formulas. A of n is equal to a plus n minus 1 times d. Looks like you don't know the last term yet. So maybe you want to use the sum formula. Sum of n is n over 2 times 2a plus n minus 1 times d. We know the sum is 246. We don't know the number yet, but we know the first term is 15, and we do know that d is 1. Okay? So 246 equals 30 over 2 is 15n plus n squared over 2 minus n over 2. So you might want to double everything. 592 equals 15n, 30n plus n squared minus n. So this is going to be n squared plus 29n minus 592. And so you're going to want to factor that. And Don't have that offhand. I don't have that. I can't factor that without my calculator, but you can. See if you can factor this. Good chance to interact here. See if you can factor this. I want to say it's in the 20s. And then once you know n, then go back, put it in here, and you can find out how many there are on the bottom row, a of n. So shouldn't be too bad. Go ahead and figure that out. And that should wrap up. We can do some more class examples using those formulas. But I think you're ready for the assignment. So here's some sigmas. You're going to set these up. Make sure that you can set these up. Look for a common difference. Like this is 3. So that's going to be 3 times n. If it's a common ratio, then it's that to the n. That ratio to the n. So think difference times n, ratio to the n. And then all of these will have sigmas, I equal to a low to a high. I equal to low to a high. Shouldn't be too bad. Great puzzle here. Can you make this without lifting your pencil? It can be done. And then all of these, you're using those formulas. And I think I have an overview, maybe not. We're going to skip these compounding ones. We just don't have time for those. All right. So one last time, and then I'll stop. I know this is a long video. I don't like to do long videos. But you have arithmetic, and you have geometric. Okay? 3 formulas here. You have the common difference is a of n plus 1 minus a of n. You have the nth term is going to be the first term plus n minus 1 times d. For the sum, there's actually 2 formulas that I like. I like n over 2 times the first plus the last. I also like plugging this second formula in for a of n to get the one we proved, 2a plus n minus 1 times d. So those are the 4 formulas for arithmetic that you're going to use. Super helpful. For geometric, the common ratio is the n plus 1 term over the nth term. You have the nth term is first term times r to the n minus 1. And then you have the sum of n terms is a times 1 minus r to the n over 1 minus r. And I have seen it in books where they go a times r to the n minus 1 over r minus 1. I've seen that. You can see the algebra behind that. But here are your 3 formulas for that. That is arithmetic and geometric sums. So we can say that we did a series, which means that we got series this unit.